computer science course, all right, so that you can have a look at what's involved in the qualification and the types of topics that you'll be learning about if you choose to do it. So let me just share this presentation. All right, first things first, the course that we do is the OCR course. So OCR, Computer Science, graded 1 to 9. In the course, you do 3 elements. You do 2 exams. Both of the exams are an hour and a half long. You can't use a calculator, and you can see some of the topics that you're going to get tested on. We also do a programming project. We use Python, and that's 20 hours in class. That work is then sent off to the exam board so they can check that we've done it and done it to the right quality. All right, so that's just a quick overview of what we do. 3 units, both 2 exams, an hour and a half long. Controlled assessments, we use Python, we make a game, a dice game, 20 hours, it's done in class, and the work is sent off to the exam board. Okay, some of the things that you need if you're going to choose computer science. You need to be okay at maths. You don't have to be fantastic at it, but you need to be okay, right? Also, you need to be interested in computers, obviously, right? How they work, how networks are put together, how you create computer programs, and you've got to be motivated, and you've got to be able to work independently. All right, let's have a look at the first exam. So the first exam, like we've said, 1.5 hours long, no calculators, and these are the types of topics that's going to be that you'll be tested on. All right, so we've got system architecture, memory storage, networks, topologies, etc. All right, so if we have a quick look at that, you might remember doing this task in year 7. So system architecture, it sounds like a fancy topic, but it's not. It's just the components. What are the components inside a computer? What does each component do? How do they relate to each other? And obviously we go into far more detail than we did at Key Stage 3, but that's what system architecture is, hardware inside a computer, okay? Another topic is system software. I'm recording this video now using my laptop. Everything that I need, all the software that I need is on my laptop. So I've got an operating system, so it allows me to use the mouse, the keyboard, open software, basically do anything I want to do with the computer. It also manages memory. I've got utility software, so I've got software that's running in the background to help me to do jobs that I need to do. Antivirus software to keep my computer protected from viruses. Compression software, making files smaller, encryption, disk defragmentation, etc. All right. So, and then you've also got device drivers. So I've got a mouse, I've got a disk drive, I've got a touchpad on the laptop. All these little bits of hardware, they need to be told how to communicate with the rest of the computer, and they need to know how to do the job. So that's device drivers. So I've got an operating system, I've got utility software and device drivers. So I've got everything I need to make my computer work as I want it to do. All right, so that's a full topic and you'd learn all about that. The second exam, right, again, 1.5 hours long, no calculators again. These are the topics that you get tested on: algorithms, programming techniques, right, translators, data rep. All right, so let's have a look at the first one, algorithms. All right, so what I've done is I put this together. It's easy, this really. So I've typed in Rory McIlroy because he's the best golfer on the planet, right? And the top 2 hits were his own page and his Twitter account. The reason those have come to the top of the search is because they're the ones that have been most frequently visited. So the most hits come from his homepage or his Twitter account. But it's like, well, all right, how did that happen? So let's imagine that that's a website and it had 50 hits. That's a website and it had 2 hits. That's website number 3 and it had 6 hits. Website number 4 and it had 8 hits. All right, so how does this algorithm work? Well, first of all, you'd go to the first 2 places and then you'd say, right, the number on the left, is that bigger than the number on the right? And if it is, you'd swap those numbers. Okay, so the 50 then would be in that position. All right, then you'd move up and you'd go up another element and then you'd do exactly the same thing. Is the number in that position bigger than the number in that position? And it is. So you would swap those numbers around and you could see that the number 50 is then moving along. And all you do is just keep repeating that and repeating that and repeating that. So we move up another element and you do it again. And what you'd find straight away is the biggest numbers, they would bubble up to the top. So this algorithm that we're looking at now is called a bubble sort. So we sort in the numbers into the biggest to the smallest, but the bigger numbers bubble to the top. And that is one of the ways that you get the most frequently visited websites bubble into the top of search engines. If I'd have come up with that before Google, I'd have been a multi-millionaire by now. All right, I think it's a really easy algorithm to do. So you'd learn about different algorithms, how you sort and search through data. All right, data rep. So some of the things we've been doing, sending the work out to you during this lockdown, we've sent some data rep out. Data representation is easy. This is where you're doing quite a bit of the maths. So that's a processor. Processors are parts of a computer. Computers run on electricity. Electricity can either be on or off. A 1 is on and a 0 is off. So if a processor can only understand the ones and zeros, we need a method for representing letters, numbers, punctuation, symbols. All right. So let's have a look at this. I've got 128, 64, 32 going down to 1. These are the place values. 128's got a 0 underneath it, so that is switched off. So I'm not going to bother with the 128. 64's got a 1 underneath it, that's switched on. So I'm going to add 64. 32 is switched on, so I need 64, add 32. 16's off, 8 is on, 4 is off, 2's on, and 1's off. So that adds up to 107. So that binary number there, right, adds up to 107. And if you look there on the red line, 107, which is the same binary number, that is a letter K. So when I've typed in that letter K there, that's what I see on the screen, but the processor sees that. So think about this presentation. Can you imagine how many ones and zeros there are just in this presentation? Can you imagine how many ones and zeros there are just on this slide? A lot. So processors only understand ones and zeros, and data representation is working out how, when we type in letters or symbols, what the processor sees, and how do we work that out. So that's a full topic as well. All right, the final section is the Python project. All right, so that might look scary to you. You've never done any programming before. You think, I can't do that. Programming, it becomes really simple, because it's what you find is you're using the same skills over and over. It's all written in a very similar way. You can copy and paste big elements to it. And underneath at the bottom, you'll see how I've done the scheme of work. So this is the system architecture topic. And every week, right, out of the 3 lessons that you get in a week, every week we do one of those lessons that always be programming. So you're constantly doing programming throughout the course. You can see we're doing variables there, we're doing if else, we're doing functions. Okay, so you'd be doing 1 hour, or well, 1 period, 50-minute lesson of programming each week. And even you're looking at it, you think, well, it looks a bit scary that by the time you come to doing your controlled assessment, which would be in year 11, trust me, you'd be showing me new skills, right? So you would get good at it and you get good in short order. All right. So that's it. That's computer science. 2 exams, 1 project, Python project, and you know, I hope that you decide to choose computer science. All right. See you later.